So let's start beginning this session. So welcome everyone. So this is the first machine learning coffee seminar of the year. We will be organizing these every week, and we will have high-profile machine learning scientific presentations, mainly from the Finnish machine learning community. And we start with an amazing talk, which I'm sure will be amazing, by Kaski, who is the head of FCAI, and he's going to be talking about collaborative modeling with AI. So please, Sami, go ahead.
Thanks, Markus. No pressure. Amazing talk coming up. So, right, and thanks for Markus and Luigi for running this show. And of course, it's a big honor to be invited in this high-profile event. It certainly is. I mean, this is a high-profile event for me. So, just let me see if I can get the presentation up. So you can see the presentation screen. Can you see my mouse now? Pointer. Yeah, all right, great. So I thought to do, if I can pull up somehow the chat box, I thought to ask for feedback in this Google Doc that should be accessible to everybody. I put that to the chat box. For the purpose, I mean, any questions and feedback, scientific feedback, welcome as normally, and you can also ask online. But I would also like to hear kind of which parts were understandable based on your background, because I found out that it's difficult to present this stuff to people with mixed backgrounds, because it is possible to understand the phrases I'm using in very, very different ways. And I'm trying to learn to anticipate those. So any feedback you can put to the Google Doc would be highly appreciated. Thanks. And let me get your faces on the screen so that I can see the my notes. All right. Yeah, now your faces are somewhere really weird. Okay, but let's start. So this talk is about what we mean when in FCAI we talk about AI assistance. And we normally mean two things. One is a much broader understanding, which is essentially any AI techniques that can help their user in decision-making, modeling, design. And if we now mean AI broadly, so it's not only some specific machine learning algorithms or some specific classic AI algorithms, but any computational tools essentially meant for inference or learning or decision making. This is actually a really broad and meant to be inclusive definition, meaning that there is room for anybody in the Helsinki or other places to collaborate in this research. But then we have additionally, in addition to this broader definition or meaning, we mean very specific new types of artificial intelligence, which FCAI develops and applies. And I'd like to start the presentation by a quiz. And now I can't see the Zoom and so on very nicely, so let's try to have this quiz as whatever works well. Now I can have your faces where I want to. I updated Zoom this morning. Apologies for this mess. So, so what do we really want from AI? And now it obviously depends on the task. So when we are listening to music or buying something online, so what would we want from AI? And now I'd like to really have the hand raises, but I can't see your hands so well. So I'll try to answer myself. Feel free to put your answers to that Google document. So at least for me, I would want some assistance on finding stuff that I like, or then maybe sometimes I'm looking for stuff that I didn't know existed, so I can't find it myself. But if I get a recommendation, I would recognize that, oh yeah, that's cool, I'd like to try that. So it's clear I would at least need assistance in that case. So what about healthcare? So what would I want my doctor to have, or what would the doctor want to have when treating patients? To me, that depends on how good the doctor is, or ultimately whether I trust the doctor, right? So if I trust the doctor quite a lot, and I typically do trust the doctors, then I would like the doctor to have the assistance. But there should be, but the doctor would make the final call. Teemu, I see your hand now. But yeah, chairpersons, please tell when somebody is raising their hands. I may not notice.
The Google Doc is we need to request edit access separately, so we can't edit it at the time being. I think you can change that if you share it again with anyone can edit mode.
Right. I tried to do that, but something went wrong. So could I request that let's have the talk and then I'll fix that, and if you make your notes separately, then just put them afterwards or send to me.
Yeah.
All right. Yeah, thanks, Teemu. Okay, so in court, so what would we want lawyers to have? This is, of course, a topic that is being discussed quite a bit, because there is also the point that the decisions that judges make may be biased. And we would want to have more objective tools for the judges so that the decisions would be fairer. So here again, it depends on whether the doctor can bring something additional in, or whether it is just whether we just want to automate. But in some cases, we might want to have an automatic judge, or we might want to have an automatic doctor. For instance, if a doctor is not available, I would certainly rather have an automatic recommender system or automatic doctor than nothing. Then a harder task. So when we are sending a robot to mine minerals from an asteroid, what do we want AI then to do? At least my answer would be that, yeah, I would rather like it to be reasonably autonomous, because the messages, any commands that we would be sending it would come too late if there's some disaster looming. So at least some degree of autonomy is needed. But on the other hand, I still would want the robot to do what I want, right? So I'm sending it for a purpose, and I'd rather want it to fulfill that purpose than have its own purpose and go off conquering the world, for instance. So the crucial thing underlying this that I tried to evoke was do we want automation or do we want assistance? And at least my thinking would be that very much depends on the case. But what is common in all of the cases that we covered here is that there are always some humans in the loop, in very different ways. In the recommendation engines, where the human user is giving feedback all the time, and in the court cases, maybe depending on the case, whether it's complete automation or instance, and in the mining the asteroid case, it would be automation, but with the goal given by the user one way or the other. So now here I'd like to quote Stuart Russell's center, Human Compatible AI in University of Berkeley, California, who says that we need AIs which are beneficial to humans instead of just building intelligent behavior. So AI should aim to achieve our goals instead of their goals, their own goals, which might be a traditional definition of intelligent behavior. So intelligent behavior is something which has a goal and is able to reach it. That would be the simplest way, I suppose, to define intelligent behavior. So now this brings up an interesting problem. So how does the AI get to know the goal? And this is what I hinted to by the asteroid mining example. So traditionally, we would give explicit instructions. And this, of course, would be called programming. And if we have really good libraries, then the programming can be really high level. We don't need to specify everything. But anyway, we need to specify explicitly what we want the assistant or agent to do. This problem, underlying this problem, there is also an interface problem. So how does the user communicate the goal? And now with this, I don't just mean some graphical user interface on a computer screen, but general interface on how do we communicate? Is it natural language? What kind of language? What concepts can we use there? It's necessary to solve a machine learning problem. So how does the AI learn it, unless we want to explicitly specify the goal, which we may not always be able to do? And then there is an AI problem, which is of course overlapping with these, how to formulate the setting that I was now describing formally, so that we can start solving it exactly. And how do we specify the AI's task in that setting? So that's where we come to the AI assistance problem. So the problem would be how to formulate an agent, which we call an assistant, which is capable of learning to assist another agent. And now I'm using the terminology that it's both of them are agents, but I'm talking using the term agent for the person or entity that is being assisted, and an assistant is the one who is doing the assistance. And now a particularly nice formulation of this problem is that we have an agent that operates in an environment. So some external environment. And now if we are talking about AI-assisted decision-making, for instance, then the environment is where we are making the decisions, right? So it could be the patient that is being treated, or it could be then the asteroid in which the robot operates, and so on. So the agent is choosing from among a set of actions and then observing a state of the environment, and some of the state can be unobservable. So we are talking about Markov decision processes or partially observable Markov decision processes. And now what makes this particularly nice is that the assistant is not acting directly in the environment. Its environment is the agent, so it's giving advice to the agent. So it observes what happens in the environment, but it doesn't make actions directly there. So why this is nice is because it takes out much of the complications of this setting, and it requires the assistant's advice to be something that the agent wants to take into account. So the agent can always choose to ignore the advice. If the advice is not useful or understandable, then it can just follow its own policy and act like it otherwise would. So the assistant is only useful if it is useful for the agent. And then the reward or utility comes sometimes later in the down the line. So this is essentially a delayed reward decision problem, and the interaction between the agent and assistant is a simple game. So the assistant takes an action, agent responds with another action, and then they observe something, some reward from the world, now or later. So that's a tentative formulation of a setup. So of one type of setup for the assistance problem. So when we are talking about AI-assisted decision-making, design and modeling in FCAI, how does that map to this setting? So in decision-making, if we talk about personalized medicine where the doctor chooses a treatment, then the A, this is the doctor, A would be the treatment that is being chosen, S would be some measurements now or later of what happened to the patient, and the assistant would be giving advice. So for instance, could be suggesting a treatment or telling that if you treat in this way, then I would predict based on the data that I have that the patient, what will happen to the patient is the following. That would be a simplest decision-making scenario. There are more complicated ones, of course. Design. So now the agent is the designer, and the action would be a design change. So now we have a motorbike and we would like to make it faster. What would I change in the motorbike to make it faster? Then I would observe that, okay, now it would be faster, but it would have maybe the fuel consumption is so large that I, after all, don't want to have it. So the advice would be a suggestion for the design change, and then some predicted properties of the design, which the agent can observe and decide whether to follow the advice or not. Modeling, the action would be a modeling choice, and A prime would be a suggestion with potentially already showing some modeling results. Right, that would be the setting. Simplified version, to make this more concrete, is knowledge elicitation. So now here we have no external environment. We just have the agent and the assistant, but otherwise this can be the same thing. So the actions and the interaction can operate in the very same way, based on, for instance, some simulated results. So now the assistant essentially queries by giving a suggestion, or it can be a question, or more generally, it can be any change in how it behaves with agent. So it doesn't need to be a question. It doesn't need to be a specific suggestion. It can be any change in their common environment. So then the agent responds with which can be an answer to the specific question. It can be any other available action. It can, for instance, be the A prime can be a proposed design without measuring anything in the real world, and A can then be whether the agent thinks that's a good idea, that design, right, with the simulated properties that it has. So this can be used for prior knowledge elicitation. More general context, if you want to read more, is in a paper that we just wrote with a few groups of FCAI. And to show concretely an example, you have seen me present this before. So this is the simplest case of what I presented now today so far. So knowledge elicitation for a prediction task. So here we have simple user interaction. So the assistant is asking the expert for effectiveness, for the expert's view on effectiveness for a specific drug for a patient that has a certain characteristic, right? Characteristic of the patient would be the feature. So we ask that, do you think that a patient of this type would benefit from this specific drug, right? Then the expert answers yes or no, or I don't know. Most often I don't know. Then the system would update the prediction model, and based on the updated prediction model would decide which question to ask next. And the utility here would come from whether the predictions improve. So actually here we do have external environment in the sense that the prediction model is being validated on some data set that only the AI has, but the user does not see that. So in that sense, this is prior elicitation, right? If the user would see that, that would change the problem setting completely. If we talk about prior elicitation, then the user wouldn't see it. So the task essentially, the prediction task that they want to solve is predict Y given an extremely high dimensional X, which is so high dimensional compared to the size of the learning data set that you can't solve this statistically. You need to get additional information, and that is why we are doing prior elicitation in this case. So if the expert can tell which dimensions are important, the dimensionality has been reduced to a feasible number, and then it is possible to learn from the learning data set. That's why this would work. And it actually does work. So this I have shown before. So for a prediction task of predicting based on genomic data, blood cholesterol levels in a set of patients, small set of patients, we constructed a simulated expert which has seen a bigger cohort and is answering based on relevance in that bigger cohort. And now as the elicitation, number of elicitation questions increases, the predictions improve, prediction errors decrease. And we went ahead and did the same things with real experts as well. So now going further or towards what I'm going to talk about in the rest of the talk. So in this case, we have to make some assumptions of the user in order to decide the next question. So essentially, we need to build a model of how does the user answer and how is the user's answer related to what actually is relevant in the world. So in this case, let me move your faces away. So we have a linear model based on the X, which was the genomic properties. We are predicting the effectiveness of the drugs. with the linear weights being W. Now what we assume here is that there is some true relevance of these features, which we just don't know, we meaning the AI here. Now when we ask the user answers whether the feature is relevant or not. And now we make two assumptions. The first assumption is that when the user is answering, they are answering about the real relevance, but they may not know the real relevance, and instead they may make an error. And there's a probability for them to make an error that depends on the drug, maybe also on the patient, but in this case on the drug, which we also don't know. So now we changed the problem of just estimating linear weights for predicting treatment effectiveness into estimating the linear weights and then the relevancies and the error probabilities of the users, right? So now we have many more variables to estimate. Why does this make sense? It makes sense because now we have more data. So we can ask the user more times, and each question from the user provides us new evidence. And now if we ask sufficiently questions and the user has some knowledge, the predictions will start improving, and that's what you observed in the curves. All right. So that's an example on prior knowledge elicitation, which was the simplest case of the AI assistance problem. Now, why is this not sufficient? I mean, it would be really nice just to assume that the users give us evidence unless they don't know, and if they don't know, they would make errors, right? And then we just estimate the error probabilities. All would be fine. We have changed the AI assistance problem into a probabilistic modeling problem, which we know how to handle, of course. Why this is not so simple is because people do not just passively give information, right? If I'm asked a question, I'm not answering the question, I'm thinking, how do I benefit from the situation by answering the question? Well, I'm exaggerating a bit. Of course, in science, we tend to actually try to answer what is true, but in many other cases, we wouldn't. So here is evidence from a simple game where the AI asks for values of a function to find its maximum. So the AI does not observe the full function. It's a one-dimensional function. So we can simply visualize that. The user does know the function. The user sees the function. And now the user's goal is to help the AI find the optimum. Right? The AI asks, what is the value of the function at this point? What about at this point? And the user's task is to get the AI to find the optimum as quickly as possible. In this case, now this maps to the earlier setup. The A prime, the question from the assistant is, what is the value of the function of x? And the action of the user is the user given value. It turns out that human users are able to help the AI get to the optimum quicker or to the maximum quicker. This is a certain mapping from how quickly they get to the optimum as a function of the iterations compared to Bayes optimization with a decent kernel function, which is a really, really good benchmark here. So how on earth do they do this? The answer is that they have an agenda to help the AI, and they try to predict what would be useful for the AI, or what would the AI do if I answer in this way. And it turns out that they can help the AI get there quicker. I'll be glad to explain this in more detail to those who are interested. And it turns out, if you look at this more carefully, that the user actually does not give the correct value, and that helps the AI. That's what I said now in other words. So a conclusion from this, to me, is a user model, or more generally an agent model, is needed even in these simple cases. And it needs to have something more than just accounting for the noise or errors in the user's answers. All right. So that was to make this concrete, simplified setting, knowledge elicitation. So then to a case which is a prime example where we cannot completely automate, which is AI-assisted design. So I already hinted at this. So in this case, the designer has a design in mind, or maybe has designed an artifact. We can talk about drug design. We have a drug molecule, and we want it to have certain more useful properties, such as it's actually curing a disease, and it doesn't have side effects, and then it shouldn't infringe on others' patents, and so on. Or it can be the motorbike that I already mentioned. So now what the designer would be doing is thinking of a design change. So how should I change the design that I now have? And I would probably start thinking that, okay, thinking of the motorbike. So, okay, it would be nice to have a fast bike, then I could move in this way in the design space. So change the design to these directions. But then on the other hand, I should remember also that the carbon footprint of the motorbike. So nobody's going to buy these soon if they have a huge carbon footprint. So I need to take that into account as well. And typically, I wouldn't be able to write that down as an objective function, because there are many constraints in how to build a motorbike. I would only realize what my options are after I have made some choices. That's why this can't be done simply by optimization, right? Writing down an objective function and optimizing. Instead, it would be an iterative process of making a design change, then studying what the new object would be, and then making a change as well. And if it is very laborious, we humans certainly would have an agenda, or we would try to plan how to get to the desired solution quicker. So now in this case, the AI assistant would observe, first of all, of course, the current design solution, and then the design changes that the user proposes, and then at best it would be able to suggest some designs, some choices that the user didn't think of that might be good for the user's goals, which in this case would be the certain objective function which the user just cannot explicate. Right, so and the AI assistant will be able to help the user if it is able to extract the user's objective function quicker, better than what the user is able to do, or if it is able to give, based on knowledge that it has, recommendations that the user doesn't come to think of, right? But for both of these, it needs to understand how the user is planning, so that it can give the right recommendations when the user would want to have them, right? And then, of course, they need to solve the user's problem. So an example of this would be a day trip planning example. So which places would you want to visit while having holiday in Paris, where you would want to balance between the price of these different visiting locations, time that it takes in each of them, in total, time that it takes in walking around, and then enjoyability of these different places for you and for the family if you are going with family or friends. Right. So how the design would work in this case is you would have a trip, that's the design, tentative trip, then you would start considering, should I change this trip? Should I include, in this case, Louvre, or should I include Eiffel Tower? And now the AI can make suggestions if it knows roughly already what your cost function is. It can try to make suggestions which would be good for your cost function. And now in a simple demonstration or simulation on simulated users, if the user is assisted, they get to better trips quicker than if they are not. That's a really brief description of this. I'm sure that Sebastian de Perter is willing to give a longer talk on AI-assisted design and this specific case. So by now, I hope it is clear that we need user modeling, modeling of other agents, more generally. So what do we need of user modeling? So we need a generative model which is capable of producing goal-driven behavior with constraints, right? So the user certainly has constraints, time constraint, cognitive constraints, and so on. And this is such models are called computationally rational models, or computational rationality is the field that develops and studies those models. Additionally, we need user models that include other goal-oriented agents in the environment. And furthermore, that the other agents also build representations of other agents. This is what is called in psychology sometimes theory of mind, that we humans have a theory of mind, and our AI assistants certainly don't have a theory of mind at the moment. So why do we need these? So the simple reason is that when I'm trying to explain to my AI assistant what my goal is, I'm not just explaining the goal, right? I'm trying to take into account what the AI already knows about it, right? In the same way as if I would be explaining to any of you guys what I'm, or as I am explaining to any of you guys on what the research goal here is, I'm trying to take into account what you already know about it, right? And then if I explain in a certain way, how would your knowledge change, right? And that requires this kind of a thinking process or planning process requires this kind of a theory of mind. We always do that when we communicate. Otherwise, our communication would be way too inefficient. So we do that. So if we want to have good AI assistants, we need to have assistants that understand that we do that. Right? Simple as that. An example of this was what we what we wrote a NeurIPS paper a couple of years back for the problem of how do we get an AI assistant to do what we want. So essentially, we give the AI learner the capability to understand that the user has a goal and a plan by learning a user model, and that it has the model of the who is being talked to. In a simple case of keyword retrieval, I'm skipping that now due to lack of time. If we give the AI this kind of capability, we get better behavior than if we don't. So it actually does work. So now this is a real user using an AI assistant as a keyword retrieval assistant. So how did we do this? So we consider the user, we being the AI. The AI considers the user as a teacher which is trying to explain to the AI what the goal is. And now the user assumes that the AI also has an agenda. Okay, and I'm sure that Mert Selikuk would be interested in talking about this, or Pierre-Alexandre Murena if there's still slots open. So then the last thing I promised in the abstract was POMDPs for centaurs. So centaur here is agent assistant combination where only the agents in the environment. So this is roughly what I started with. So if we now call that the centaur, entity which produces actions and observes some states. Its internal workings are what I described here. So now the crucial property here is, as I explained, is that the agent can choose to act by accepting the assistant's recommendation or implementing its own action, but then implementing it themselves may carry an extra cost. So that's the reason why we want automation. We want advice that make our life a bit easier, isn't it? Right? So if we formulate this, we get essentially we get POMDPs. If we want to make them learning, we need to make them Bayes adaptive, and that's what we wrote a paper with Mertz-Selikuk, Franz Olihug, and it has become accepted in AMAS. And Mert would probably want to talk about this, so I'm saving you of the double talk now. Okay. I also mentioned AI virtual laboratories, AI assistants I have already been talking about. So how is this related to the talk? So the UK's Basic Research Funding Agency, UKRI, gave me a grant for studying this core problem and develop methods for solving it and applying them to what I called human AI research teams. And the research question here is, how do we steer an AI assistant to do what we want when we cannot explicate that to ourselves yet? And this, if you think about it, it's another side of the same coin that I was talking about. So the other side of the coin is, how does the AI learn? What does the user want so that the AI can assist the user? The other side of that coin is, how does the user tell the AI what they want? And of course, the answer how to solve this is to build an assistant which is able to infer it even from indirect cues when the user is not able to explicate. So this is a very similar grant to ERC advanced grants, but bigger and specific to AI. FCAI is a key collaborator in that research, and that's very fitting to the FCAI's vision. So AI-assisted virtual laboratories. And AI assistance here means roughly what we have been discussing today. What virtual laboratories mean, that in if we are thinking of all tools that are needed for computational research in a specific field, such as materials research, we could call those tools, the combination of those tools, a virtual laboratory, instead of the wet lab or the physical laboratory of physics. We would have a computational laboratory. And now why AI assistance is needed there, or what AI assistance there means, it's those intelligent techniques that can be applied across the different laboratories. And I'll just finish up by thanking collaborators, and for some really weird reason, I don't see the image here. I have to debug that afterwards. All right, so anyway, there's supposed to be a figure of the group containing the names of some of those who have been cited this work. The others have contributed in other works. All right, thanks. That was the talk. I'm very willing to take questions.
Okay, thanks, Sami, a lot for the talk. So any questions? Please either raise your hand or write in the chat. So Jörg, can you start?
Yes, thank you very much. Very interesting talk. I also agree that it's really important to model the user and create some kind of behavior that knows how to react in user interaction and so on. So I find this really important. One question, I actually have two questions. One question is about the risk that we might develop some systems that simply want to please the user. So if you have now some user modeling and then it knows what the user wants, what kind of plans and goals the user has, then we come to the same problem that we have already at social media, that the system, the AI system, is now just simply pleasing the user, giving the news that the user likes, creating this bubble that you only see what you already agree with, which again is something that I think should be avoided, because AI should help you to widen your knowledge and getting also contradictory information. And that might be a problem if you just develop a system that optimizes the user pleasing functionality of the system. That's one question. Maybe I just add the other question also, maybe related to that, is also that if a system just simply gives an answer saying we have a request and asking should we get that treatment or not, I guess if the system simply says yes, it's not enough. So how important do you think is explainability in a system, that a system either explains its decisions or gives evidence why it makes that decision, or is in a good way interpretable, so that you also know why does the system now gives me this information, and how does the system argue for its views. Those are the two questions I have.
Yeah, thanks, Jörg. Excellent questions. So for the first one, yes, I fully agree. So kind of developing those kinds of bubbles would, I mean, we've already seen that what that leads to. In this case, what gets us out of that is that the utility comes from the environment, which is external to the user, right? So if it was only the user and AI, not having some external measures of goodness of performance, then that would be the problem. But in research questions, if the result will always be tested in the real world in the end, and that is the source of the utility, that gets us around at that. In general, of course, I mean, underlying what you are saying, there is the even trickier question, is that now the AI could, in principle, it could mislead the user if its reward is somehow just dependent on the user, or even partially dependent on the user and not only of the real world, right? And yeah, this is something that Stuart Russell has been writing quite a bit. So I don't know if you have read those, but I thought those were enlightening. So for instance, that of course, the first thing a reinforcement learning agent is doing, if there is an off button, is it finds a way how to shut down the off button, because that if the user presses it, it stops the AI achieving its goals, right? So that's the simplest example of what can go wrong, isn't it? Okay, but then for the so for these kinds of research type questions, I don't see that problem. Then the researcher will just not be able to solve their problems if they don't listen to advice. So in science, this is easier. If we install these in the society for other purposes, then this is a really important thing to take into account. Okay, then about the explainability, interpretability, hugely important. I would actually, and it's even so important that that's one of the core design factors on why I am proposing what I'm proposing, right? Because now if the AI's task is formulated as I did here, then there's no way around the AI having to be explainable. Because if it is not interpretable to the user, then the user just skips it, right? So this kind of an AI cannot be non-understandable, right? Otherwise, it's just it goes to garbage. And what I mean by this is that any explainability needs to be ingrained for it to be useful. So I'd say that it's crucial, and it's already inbuilt in the design that we need to have it. So we have a measure of explainability in this case, instead of somehow post hoc implementing it to machine learning tools, which are really complicated and hard to understand.
In what sense would you see explainability as the best development? So would it be the most important thing that the system can explain itself? So its decision saying we don't need to interpret it all the internals of the system from the outside, but the system itself can argue. Is that a way that we should go forward with, or would it be better to have a fully interpretable system that we can explain from the outside?
That's a separate research question to which I haven't studied, so I don't have a justifiable answer to that. What I'm just saying, how I'm seeing this, or what I'm trying to do is to have an AI that is trying to make a sensible compromise between those two. Because that depends also on the task, right? Mm-hmm. Sometimes we really want to understand everything. Sometimes we just want good advice. Mm-hmm. And if the AI can personalize to the task and the user according to what they want, then it can help the user solve their problems more efficiently.
Or maybe showing evidence why it makes certain decisions.
Right. Yeah,
supporting its decisions and things.
Yeah. Maybe I want to highlight still that the advice that I showed here, I just had A prime there, but that doesn't imply that it would be just a recommendation. It can also be showing whatever kind of complicated neural network and your favorite visualizations to justify why the decision, why the recommendation is as it is.
Okay. Thanks.
Okay, we still have maybe a few minutes time for a quick question from Anna.
Okay, thank you. So I would like to ask a little bit, like, you see this, what is assistance? So how I was taught in business that you always start from business problem and then you try to find some solution, some kind of machine which does it better, faster. And this is the main philosophy, that you always have to have something from life to solve it. For example, searching a movie, something you anyway do, and then you use a machine which does the same, better, faster, cheaper. What would you comment on that?
So in what sense would you call that assistance? I'm not sure I understood that. I understood
mean,
the
for
question,
example,
but...
because usually when people start from AI, they think about what AI can do, but they should start from life tasks. So for example, or from business tasks. The doctor anyway tries, let's say, to look at the cells which are malignant and which are healthy, but doctor cannot watch thousands of cells and cannot look into details. So that's why he just asks machine to do the same tasks he did earlier, but better, faster, and cheaper, because he cannot process so big data. But the task is the same. So my point is that those tasks for assistance, they come from real life, what people already do.
Right. Okay. So I think we have two different dimensions here. So one is that do they come from real life? In the cases that I'm describing, they definitely do. But the difference is that I think what you are describing now is automation. So you are assuming that the task is well defined. So in the real life task, somebody is able to specify exactly what the doctor is doing. And then we have a few examples, cases from which the AI can then learn to repeat the same thing.
Yes,
that would be,
yes.
to me, pure automation. So what I was describing here is, and I would not call that, but that's my terminology, but I would not call that assistance, because there is no human then later anymore, right? It's the AI it's automatic decision making, right? So what the problems I was trying to describe now is where the AI, where we are not able to specify the problem. We do have real world data, but we are not able to specify the problem explicitly, such as in the design case. But instead, the user, there is an expert user who has knowledge that the AI doesn't have, and then together they need to arrive at the problem formulation and solution, so which could be then, for instance, the treatment decision.
Okay, thank you. So it's totally other task. It's not automation anymore. Yeah.
It's to automate the assistance as much as possible, but we can't automate the user out from the loop. That's maybe my definition.
Thank you.
Yeah, thanks for the question. By the way, for the Google Doc, so to me it says that anyone on the internet with this link can edit. I don't understand what goes wrong, so let's try to solve that. But any feedback that you have, if you are willing to send them by email to me, then it's...
Yeah. Sami, I already created an alternative Google Doc which works. I've shared the link on Slack.
All right, wonderful, thanks.
Yeah.
Can you put to the Zoom box, chat box also, if you didn't yet? Oh, you did. All right, thanks.
Okay, so we are a few minutes over time, so maybe we can conclude this session. So thanks a lot, Sami, for your really interesting talk, and also thanks for the audience for your interest. So we continue next week with the talk by Antti Honkela. So have a nice week. Goodbye.
Have a nice week. Bye.
Bye-bye.
Yeah, this was really nice. Really nice talk and lots of discussion.
Yeah.
So I think we had a record. I think we had 55 people attending, which I think is a record.
It's a very good start.
Yeah, that's a great day.
All right. Glad to hear that people are interested.
Rush forward.
Bye.
Thanks. Bye.